Hello, good afternoon, it's David Emily. I'm coming at you with another VUCS Harvard CS50 help video. Today we are doing substitution. Now I think this was an optional one. We only had to do the Caesar, but I thought, what the heck, let's do it, let's knock it out for anyone that wants to do it or just wants to know how I did it and compare, what have you. So I'm going to be going through this one a little quick. I feel like I said in the last one, I'm just going to try and do all these videos quick. Let's just do that. Cool. So starting out, I've got what they have, what they prompted us with. I already input the libraries. And basically in this assignment, we're getting a key. It's going to be 26 letters. And then we're going to use that alphabet as our alphabet to encode stuff. So much like Caesar, but we're only going to kind of abuse the C language even more with how letters turn into numbers and vice versa. So I think the hardest part of this assignment was starting off and validating their input. So their input can't have more than one duplicate. And then the other part was just making sure that if they enter a lowercase number, we give them the coinciding lowercase version. So that'll make more sense once we go into it. So let's just start. So I want to start out with just first taking what they pass in. I think this thing has a rule saying that if it's an invalid input, we want to return a 1, and if it's a valid input at the very end, we will return a 0, as well as printing out the thing. But kind of how we did last time, we want to check to make sure that what they enter is only two different things. So we want them to enter the name substitution. Substitution. And the second thing they enter is going to be the key. And the key is going to be 26 characters. If what they don't enter, if what they enter is more than 3 different strings, we just want to kick back and return a 1. Alright, so now we know they entered that. We want to check to make sure that what they entered, the thing that's in argv1, is 26 letters, because we want that to be an alphabet. So first, everything in argv is a string. We know this because up here. So let's just check to make sure that the string length of that is 26. So let's just say if string length doesn't equal 26, they didn't enter the alphabet, they entered something else. So we want to do the same thing up here. Alright. Real quick, I'm just going to go ahead and make this and run it, just to make sure that we are on the right path. Extraneous parentheses. Don't want that. And I'm actually going to go steal one of the alphabets they use, because 26 is a lot of characters. Put that in. Cool. We didn't get an error. Let's just duplicate this O on the end. Or shoot, I'm sorry, let me just add like an extra one. So this will be more than 26. Cool. So that, let me add just another case. Cool. So we know the logic we have right now works. So moving on. They entered a string. We now want to use that string as a new alphabet if we can. And to do that, I'm going to make sure that they're not using any kind of duplicate letters, I'm going to create a array of bool values. And this bool value is going to be, this array is going to be 26, length of 26. So if they enter, let's say, an A, I'm going to go up here and I'm going to mark the A value as true. And then everything else is going to be a false. If they come in and enter a C, I'm then going to set this F to a true. And then if they come in and enter a C again, I'm going to realize that's already been used by checking if the C spot in this alphabet is true. Alright, so I'm going to start that out by, we're taking in their string, I've got that. I'm going to make an array. I can just use this 26 number because we already checked to make sure that this length up here is 26. So I'm going to call that the key. And then I'm going to go and I'm going to set up every character inside my bool array as false. I think this is a requirement in C that you go and you initialize every character in there. And I'd even make this array, so let me go do that. So here I have this array of bool characters, 26 of them, in an array called already used. And what I'm going to do is I'm going to go in and I'm going to, every character in this string that they use, I'm going to make sure it's either uppercase or lowercase, and then I'm going to input it into this key. And this key array is what I will use in the next problem, or the next part of the problem. So let's start off with this. I'm going to say for int I equals 0, I is less than 26, I plus plus. And this is going to go through everything on the entered string. And we want to make sure it's an alpha. If it's not an alpha character, we want to use the same printf return that we did earlier. So actually, let me go ahead and just set that up real quick. So if alpha entered string of I, so if that index is not, or is an alpha character, everything's good. Else, if it's not an alpha, that means it is a number, and we want to hard return. I think in the example they say, please use only letters or something. I don't think they actually test against this. I think it's just whatever you want, as long as you return the 1. Okay. So I'm going to move that down. So now in this part, inside this if block, we know everything we are working with is a alphabet character. So the way we're going to divvy this up, because in my little drawing, I want both big A and little a to be covered by this true-false. I want to keep track of a character's uppercase and lowercase number by here. So what I'm going to do here is, we know that the A character minus A equals 0. So I'm going to use my true-false array to keep track of that. And I'm just going to subtract whatever character I have, depending on if it's uppercase or lowercase, with that coinciding A, to make it fall between 0 and 26 for my bool array. So here, if is upper, I think is upper is all lowercase, is upper, entered string, I. So if the current index is an uppercase, we want to, if used already, which is our bool array of entered string I minus A, because it's an uppercase, we want to subtract it by big A. If this is true, that means there is a duplicate character in here. I think it's just an extra parenthesis. So we'll printf and say key must not contain duplicate letters. And then just for troubleshooting help, I'm actually just going to print that character in case for whatever reason I need to come back and see what's going on. Okay, and then we're going to return 1 because we return 1 on failure. If it is not in there, that means it has not been used yet. So we want to keep track that we enter that value in. So I'm going to change that letter or that bool in the used already array to true. So I'm just going to say used already entered string I minus a equals true. So let's say this index of entered string, the very first one is an A. When I subtract capital A, that means I'm looking at the very first index, index 0 of used already, our bool array. And I'm just going to set that to true. So this logic is pretty confusing, but I think once you start playing around with it, it'll become a lot more natural. And then now that we set to check for duplicate numbers, I'm just going to set that string as the number in there. So now this key, I'm just going to erase all this. So then this key value is also another array, and it goes from 0 to 26, and this is going to become our new alphabet. So the way they enter it is how we want to use it. So if they enter a T, let's say a TFC, we want anything we enter as a string for the A is transferred to a T, anything in a B is transferred to an F, and anything with a C to stay a C. So the way I'm going to do this is I'm going to write this key array right here. This is my key array. I'm going to take whatever they have in their first spot, and if it's an uppercase, once again, I'm subtracted by an uppercase A, and if it's lowercase, I'm subtracted by a lowercase a to get it between the numerical values of 0 and 26, and then I'm going to put it in my key. So if they enter, let's say a C here, this first spot's going to be a 3. And then if they enter a D, so if the string key they enter is C, D, E, I'm going to set it up so this key string now holds 3, 4, and 5. So then when we go down the road, we can convert that back into the letters they put in. So I'm going to mark that here as entered A. So this handles the uppercase. We've now checked to see if it's been used, if we're playing with any duplicate numbers. We've checked that here, and then we've loaded up our key array, which we will use to cipher their text that they come in. We handled uppercase, so now let's handle lowercase. Because at this point, due to this if statement, we know it is a letter, and if it's not uppercase, it must be a lowercase letter. I feel comfortable using an else statement here. So if it's not uppercase, it's a lowercase. So we're pretty much just going to do the same logic we used here. I'm actually just going to copy this. Oh, I shouldn't have copied that because that looks gross. I'm going to tab this stuff out and make it more readable. Okay. Actually, I shouldn't have done that. That's actually totally fine. So if it's lowercase and it's already used, subtracted with a lowercase a, that means it's a duplicate letter. Else, we want to make sure we keep track of that letter and then load the key up with it, with its numeric value. Cool. So we have just when invalidated their input. So hopefully, let's try this again. I'll make substitution. I have a lot of mistakes, so let's go fix that. Line 36. Looks like I need a Oh, I never closed my bracket. So that bracket needs to close here. Below 36. Okay, yeah. So close that one. It looks like they have the same error on 49, which makes sense because I just copied and pasted this. Wait, I don't think sorry, I need to actually move the bracket after the A because we're using that A for the math to set whatever's in there to its numerical value. Okay. Let me try that again. Substitution. It worked. Substitution. Let me go copy this. Copy. Cool. That passed. Let me check for duplicates because that's the big thing what we just did. So let's set the last two characters to I. It blew up. Let me make sure it's working with uppercase and lowercase. Blew up. Excellent. And then finally, I'm just going to use a number because we want them to only enter alpha characters. Please only use letters. Cool. So we just validated their key thing that they entered. So next, the next part of this problem is much like the Caesar problem. We take their plaintext entrance and then we convert it to the ciphertext with the new alphabet being whatever they entered. So let's go do that. I will just hit a bunch of enters here because this is kind of like a new set of the problem. So now we will take in the string text, or I'm sorry, we will prompt them for this string we want to cipher for them. So we will use the getString command. I think what they say is all lowercase. Yeah, plaintext. So plaintext space new line. So I'm just going to copy this over to a new string called ciphertext. You don't have to. You can do all this math in the plaintext string. I just like keeping a extra copy around in case for some reason I need to come back later and change some stuff, which I don't think we will have to. But okay, so plaintext, and we just want a for loop over plaintext and just change it into our new alphabet. So simple for loop, I is less than string length of plaintext, I plus plus. So if it's an uppercase, we want to convert whatever we have with that coordinated spot into an uppercase. So if is alpha, sorry, and we only want to work on letters. So the example they have here is they have this comma. They don't change the comma. They don't change the space here. They don't change period. So we're only going to work on the alpha. So I'm going to put is alpha. If that index of plaintext is alpha, we want to convert it to our new string. If it is upper, I'm actually just going to copy this because I seem to be using this spot a lot. So if that index is uppercase, we want to set the that spot in the ciphertext equal to the key that we have, that spot, that same plaintext spot there. And since it's uppercase, sorry, we're going to convert this to A just to make sure that that keeps. So we're going to get that down to a number between 0 and 26. We're going to take this plaintext, convert it down to a number between 0 and 26. We then go into that key and get that associated number, which is between 0 and 26. And we want to add the big A back into it to convert it to a letter that we read. If it's not uppercase, it's lowercase. So here we are going to do the same exact ciphertext, but with a lowercase a. So I'm just going to copy this, change this to a lowercase. Cool. And then if you aren't using a separate string, you can skip this. If you're doing everything in plain text, you can skip it. Since I am using the ciphertext, I also want to set anything else that's not an alphabet. I still want to move it over to the ciphertext. So I'm just going to straight copy whatever's in that position of plain text over to ciphertext if it is not a letter. So that goes through and does that, and now let's print it. So let's just say printf, ciphertext, %s for string, new line, and then what we want to print is our ciphertext. Alright, let's give this a shot, let's print it. So make substitution, and then I'm going to steal this. The example they use is this alphabet. If I enter hello world, we'll return this JRSSB YBWSP. So let's just do that. Substitution, print that. Plain text, I messed that up. I'm going to go convert that. So we have all A's. That is not good. That is not what I expected to have. So let's go find out what's going on. First, let me convert this new line, because we don't want that new line there for plain text. So we're going through the string, send the cipher string is that. Going through if is alpha, okay? If it's uppercase, do that. Great. Else, do this. Setting that as that. I wonder if I have a mistake with my entered strings. Just for the time being, I'm going to take out plain or ciphertext and do everything in the plain text string and see what this returns me. And then since we're doing that, we actually don't need this. Okay, let me see if this is still all A's. Oh, there's my problem. I have a equal sign. Oh shoot, I don't know how I did that, but that's cool. Let me undo the ciphertext stuff. Okay, I have an equal here instead of an addition. Alright, because we want to add back the associated A to get it back to a readable letter, instead of setting it equal to A's. So let's make substitution again. Let me save, make substitution. Send in that. String hello world returns what we expect. Awesome. Heck yeah. I think let's run this check method. I don't know my GitHub. Fun. No whammies. No whammies. Sweet. We passed all the tests. So we successfully took in a string, made sure it's strictly letters, and then we use that as a alphabet to then cipher our new plaintext. How exciting is that? Woo! Alright, I go ahead and stop the stream here. Feel free to reach out if you have any questions. I will also try to post some of this code. I recommend you try to go through it, refactor it. This was pretty quick, and I'm sure there's lots of ways you could improve on it. So until next time, have a good one.